just as a trial of all of these keys. Bach's priority at the time was still very much with the sensorial, which is why his Christian devotion was not an issue when it came to temperament. First of all, because church dogmata on temperament was completely outdated at this point, but also because it was the way that he found, rather than pure prayer, to have a relationship with God. Beyond this, it is important to understand that temperament was not his passion, but rather a means to an end. He was very much oriented towards the divine, mathematics, and their relationship to music, but in his own words, he said he was not a lover of dry mathematical things. However, one could argue that the compositional palette offered to him by temperament allowed him to best pursue his musical endeavors, and this in turn gave him a context in which to have this relationship with God. So, the idea of musical notes and their associated frequency ratios is not exclusive to Western traditions, obviously. Which takes us to Indian classical music. There are two main strands of Indian classical music, Hindustani and Carnatic. And though they are very different, they use the same method of tuning, which is natural tuning, which is the tuning derived from the harmonic series which Pythagoras also used. In Indian music, notes are called swaras. There are 12 of them. 7 principal ones, sa, ra, ga, ma, pa, da, and ni. 5 intermediary ones. These intermediary ones are similar to semitones in Western music. And this linear sequence of notes is known as a saptak, or scale, and it repeats ad infinitum. The sa is the most important note, it's the tonic. It begins each saptak, and it's movable in the sense that that any frequency can be attributed the role of sa. But once that role is attributed in a piece, all the other notes fall into a very prescribed place. Sa and pa are the backbones of any saptak, pa being the 5th, and they're on exact frequency points. Interestingly, none of the other notes are on exact frequency points. They do not have one compulsory place. Rather, there's a range of frequency on which they are allowed to operate. This is a swarakshetra. Outside of these is out of tune. The swarakshetra is green here, and each one has a high and low delimitation. Here, the little red lines, and these are called shrutis. Interestingly, the word shruti, it means what is heard, but also what is understood by the ear. And often, shrutis are considered to be the smallest intelligible sound interval distinguishable to the human ear. So, in Indian music, we have 10 swaras with 2 shrutis each, and 2 principal shrutis. One immediately noticeable fact, and a key fact, in Indian music is its intrinsic relationship with nature. The names of the notes, for example, are derived from the cries of animals. And this is just one example of the symbiotic relationship, both tangible and spiritual, which Indian music entertains with nature. It's also very interesting to note that it seems of greater importance in India to actually think about human well-being when experiencing music. The belief is that the experience of listening to music is more positive when it is nestled in natural tuning, because some intervals are less harmonious to the human body in tempered tuning. Indian music does not shy away from dissonance in the same way that the West does, but rather it considers dissonant intervals as very active sounding, and they can convey tragedy or conflict, as opposed to the stability provided by consonants. Now, having established the mathematical thought behind the 2 traditions, it's possible to look at the way both of these has migrated to a new form of temperament. On the one hand, the West slowly ceased to attach prohibitively celestial meaning to mathematical theories. In music. Elements were just that: music, tuning, and temperament. The intellectual detachment from cosmic spheres and the compositional need for freedom paved the way to experiment with new temperament, still in this quest to mend the Pythagorean comma. This new temperament is equal temperament. The mathematical process to arrive at equal temperament means taking a scale and accepting that the octave has a value of 2 to 1 based on the tonic, that there are then 12 semitonal intervals in it, and that equal spacing between notes is solved by this equation. It's a geometric sequence of which factor r goes in the following way. This distributes dissonance equally across all keys and all notes. None is perfect. Some keys lose this distinctive color we were talking about, but all are usable. Even more usable than what Bach was able to use with well temperament. And the development of equal temperament had more to do, ultimately though, with practicality than with anything else. It allowed for instruments to sound good in every tonality, and it allowed for composers to write complex music and modulate freely. In the 19th century, equal temperament began enjoying the status that it enjoys today in the West, which is complete monopoly. If you study scores of romantic composers such as Chopin, Mahler, or later Debussy, you can really see that there's a sinuous relationship between all keys in their music, and that this flexibility was paramount. In India, the move towards equal temperament happened in the 20th century, and it was not so much by design, but more by foreign influence. Of course, musical theory will always adapt and is ever evolving, but one element really accelerated this in India, and that was the arrival of the harmonium. The harmonium was invented in France in the 19th century and popularized in India under British rule. It's now intrinsically linked to Indian classical music, but it does not offer the subtleties which were so dear to many Indian traditions, in the same way that, for example, a sitar could. So these subtleties were taken away because the harmonium is designed like a Western keyboard, and in Hindi terms, it means that you have 12 swaras, as opposed to the 22 shruti that we saw, much less the possibility of flexibility offered with the swarakshetra that we saw. Many objections were raised due to these restrictions, but also because the scale of the harmonium is not in natural tuning. It was seen as an imposter instrument, and in fact, the All India Radio banned it for 31 years in the last century. In Indian music, the transition to equal temperament meant moving from the 22 shruti natural scale to a 12 swara, all fixed and equidistant notes with equidistant notes from each other. Natural tuning is still used in India, but it stays very much more in the traditional classical spheres. Today, equal temperament is the default in Western classical music, global pop, and much Eastern music. All instruments nowadays are tuned in equal temperament, and all pieces are performed in equal temperament, whether or not they were actually written to be so. As with all temperaments, equal temperament enjoys its fair share of criticism. Some opponents to it describe listening to Mozart in equal temperament as looking at the Mona Lisa with sunglasses on. The early 20th century composers began experimenting with atonality because of the monotony of equal temperament. Equal temperament has been seen to embody the West's aggressive and imperialistic tendencies, is seen as a departure from God and from the body's natural vibrations, and it's thought that the dissonance of equal temperament can harm us physically and spiritually. But, generally speaking, those who protest equal temperament resent more its domination, not its practicality, because there is no perfect solution. So, for my last part, I would like to further this brief overview with a little look at the smallest interval in both Western and Indian music. To look at this is really important, I believe, because these small intervals, the semitone and the shruti, are building blocks, but it's also so important to get them right because they're very expressive intervals. It's also important because they're the first to be impacted as soon as temperament occurs. As we've seen, until the establishment of equal temperament, semitones in the West were always the most subject to change because of their denominative nature. If any interval was tempered, the first impacted was, as I said, the semitone. The shruti in India and its associated swarakshatra may appear theoretically less constraining, but instead, what's wonderful is it's more concerned with human sensibility. It's, as we said, the smallest intelligible interval, but it also offers musical input from the performer as well, because you could start on the same note, but actually start on two ends of the same note and have a completely different musical experience by listening to it. So this leads us to our final point, which is a musical absolute I would like to touch on briefly, and that is the magnetic attraction of the semitone. We will look at a few examples and then discuss them. First, we will look at Purcell's aria, When I'm Laid in Earth. Here, the singer is accompanied by a chromatic descending bass line called Passus Doriusculus. There is a musical need, you will listen to it, and you will hear the low notes. There's a musical need for one note to lead to the next. You could not just stop on one of them. It's almost as if the gravity of every single semitone was combined. And this gives a sense of despair and very much gives the imagery of what she is singing about, which is being buried. And all of this is done through the semitone. Semitonal attraction can also provide great pleasure in its release. We will look at Bruch's Violin Concerto. I will point it out, but in the very end of the section you will hear a trill, which is an oscillation, which simply extends just a little bit the musical tension created just before the orchestra comes back in. Contemporary music also uses this gravity for expression. For those of you who did not recognize it, that's the music of Jaws, the film. And somehow, in those two notes, you're able to experience a huge, huge, huge amount of dread, and it's a universal reaction to it. The emotional weight of the semitone is not exclusive to the West. In Indian music, all dawn and dusk rags, called Sandhi Prakash, again I'm sorry for my pronunciation, feature the very emotional interval of the lowered supertonic. So that is the second note of the scale, which is brought down. And in many ways it highlights this sort of crepuscular nature to the piece, but also adds an element of sadness. Although this sadness is not a bad form of sadness, it's often a sadness that is considered to bring one closer to God. This is one example. Traditionally in the West, before equal temperament, the breadth of the semitone was something that musicians could play with. Tension caused by a leading note or chromaticism was seen as something that could be exacerbated simply by leaning ever so slightly towards the resolution note. But with equal temperament, we've lost this. Though, if I'm perfectly honest, as a performer myself, we still use this whenever we perform on non-fixed pitch instruments, because ultimately musical precepts may have changed, but the laws of physics and of human sensibility have not. So, playing with flexibility in Eastern music and Western music can translate in many ways as playing with gravity. Ultimately, all of this is to convey a heightened form of emotion to the audience. So to conclude, Pythagoras' lifelong quest to understand the fundamental essence of reality is what fueled his musical research. To him, mathematics was indissociable from universal structure and music. And through its incarnation of mathematical ratios, music was a bridge of sorts between numerical study and the study of human sentiment. We've explored intellectual discourses surrounding exact placements of each notes in the Western scale. And interestingly, it's worth thinking of it in this way, that equal temperament has served Western classical music and composers by establishing clear guidelines. This way, composers can be more free, adventurous, or at least know where on the spectrum of adventure they wish to be. Also, equal temperament has removed an element of bureaucracy, both in making the music and writing it, which is good. I suppose that to please everyone, the ideal situation would be to perform pieces in the temperament they were intended to be played in. But obviously this would create many logistical nightmares. It's therefore worth thinking, I believe, both in Eastern and Western classical music, that as performers, we may as well have an eye turned towards the past just a little bit, and to look at past forms of temperament and how people adjusted, both from a point of view of accuracy and performance, and also as an important and sometimes lost means of expression. Thank you very much.
Thank you so much, Ms. Charlton. What would like to request? Thank you very much. Well, the thing is that so nicely written regarding Western and Indian classical music. If anybody having any question, please raise your hand and would like to request, please.
Yes, thank you very much. That was terrific. I heard an Indian harmonium for the first time the other night while we were traveling. It was playing with a transverse flute and a tablas. Could you show the scale, the Indian scale, and tell me how the harmonium, in terms of that scale, how the harmonium is actually tuned?
Of course. So, this is an ideal 22 Shruti one.
Yeah.
And it would be just that.
It would be just
so it's
that.
basically like the ones that we have in the West. It just...
So it's just diachronic?
Yeah.
Okay. It sounded like it could bend notes. Does it have a feature? Sorry, it sounded like it could sort of bend the notes
to my knowledge,
to get semitones.
once the note is created, you can bend it. And also because of the way in which it resonates, I think there's that sense of
okay.
yeah.
Any questions?
Thank you very much, sir.
I think the back.
Well, I guess someone from the back of the chairs on that side, on your left side.
Oh. So, at times I've worked with like DAWs, digital audio workstations, like any electronic software which helps you in creating bassline melodies and musical melodies. So basically they have a octave below, like they mentioned C0 and C minus 1 and C minus 2.
Yeah.
So when I've played those notes, C minus 1 or any C minus 2, so they don't create any sound. So I was wondering if they have any significance in the music, like, do they have any significance?
I mean, they have significance in the sense that they are octaves of each other. Is that
Yeah,
what you mean?
but they don't have any sound. That's what I meant.
They don't have any sound.
Like,
Are you sure they don't have any sound, or is it just that we're not able to distinguish the vibrations that are so low?
maybe I guess, but C0 has a kind of a darker sound. If you play,
Do you know what the frequency is?
I don't know the frequency, but I'm talking about C minus 1, and that's how they mentioned it.
Okay, I would need to see it, but I think it might just be that it's not at a frequency that we can perceive.
Okay.
Yeah. Yeah. I think that might be the issue. So there is actually vibration happening. It's just that we can't perceive it.
Okay.
I think.
Thank you.
I think.
One more question.
Nice talk it was, and it was really quite technical also. So ma'am, my question is that if we think about vibrations are mostly physical, you know, frequency 20 hertz to 20,000 hertz, something like, which are audible in range. But my question is how vibrations are connected with emotions, because these are just a frequency, isn't it? Tuning to different frequencies, and you will tune to different world. You will have different emotions. So can you comment on that, how different emotions, and even Indian classical music is somewhat different with Western. I want your comments on this. Means someone feels sad when he listens to some joyfulness and all this come. So how it is connected?
I think there are many theories on the topic, and many personal views. To my understanding, there's almost a reaction in the brain when things sound right. So for example, I'll explain. If you listen to a Mozart opera, the conclusion of it might just seem so perfect because it just seems everything falls into place. There's that almost is like brain satisfaction from everything working. In that same way, I think in Indian classical music, when you have natural tuning, I think it's like your brain is drawn to certain things. However, many people take all of these theories and go very far. Some people claim that listening to Bach or Mozart makes cows produce more milk. I would tend to err on sort of a safer side before claiming that, but I think it's also a question of nature over nurture. As much as we have a reaction to the vibrations, I think it's also to do with what you've heard since you were a tiny person and what you've come to enjoy. And so I think it's also hugely psychological and not just a purely physical response. It's an amazing question worth talking about for so much longer, but yeah. Thank you.
Thank you so much for the question. Thank you very much, Ms. Jordan Bergmans. We're so happy to have you on the stage. Let's have a big hand for Ms. Jordan. Thank you.
Next, we have Professor V. Kannan from SRM University, Amaravati, and his title will be Modern Mathematics in Ancient India, 16 Samples from Sanskrit Sources. A brief introduction to Professor V. Kannan. Professor V. Kannan received his PhD from Madura University in 1972. He was a UGC National Lecturer from 1985 to 1986. Professor Kannan's area of specialization are analysis and topology, and his research interests include topological dynamics and chaos theory. Professor Kannan was conferred the Srinivas Ramanujan Award by the Indian Science Congress Association. He also received the Dr. Sanjeeva Raya Sharma Ganita Award in 2009. Professor V. Kannan is a fellow of the Indian Academy of Sciences. He's also a fellow and elected council member of the Indian National Science Academy and fellow of the AP Academy of Sciences. Please join me to welcome on stage Professor V. Kannan. A round of applause for him, please.
Front and back. Thank you. Just. I thank the organizers for this opportunity to talk on my favorite topic to this august audience. The gist of the talk is most of the formulas and theories that we learn in mathematics in schools and junior colleges are available in Sanskrit books of the lore 1000 years ago in India. But I want to be a little cautious also. I am using most of. I am not saying that everything is already known. So which things are known and which things may not be known, we are going to see now. But most of them are already known. It is related to the present topic, mathematics and reality. There is one book by George Joseph with the title Non-European Roots of Mathematics. That book also conveys the same idea. It is a myth that the ideas of modern mathematics germinated in Europe about 3 or 4 centuries ago. But that is widely prevalent, believed by all. The reality is that these were developed in India thousands of years ago. Like the devotional philosophy and many other spiritual ideas, mathematics was transmitted to other parts of the world from India. You will be convinced more of this after seeing the other slides here. I am including here a list of 16 samples. The first 8 are given in this slide. Hypotenuse theorem, known as theorem of Pythagoras, is from geometry. The sine tables belong to trigonometry. Then an algorithm to find square roots, it pertains to the area of number theory. Then a rational function very close to the sine function, it pertains to approximation theory. Formula for the diagonals of a cyclic quadrilateral. This formula links algebra and geometry. Then naming of time duration, some kind of calendar making. This pertains to astronomy. The circumradius formula links geometry and algebra. Arithmetic progressions is in algebra. Infinite series is in calculus. Binomial coefficients in combinatorics. Recurrence formula in discrete mathematics. roots of a quadratic equation